Sensei, before we start with official, we have omiyage.
Oh, thank you very much.
A lot of things we have brought for you. First of all, the flag.
Oh, yeah.
Okay, thank you. And we brought Taiwanese sake.
Oh,
You can enjoy it. And this is tea and cake.
ah,
And thank you for the arrangement.
my pleasure. Thank you very much. So, I will start. This morning, at first I will give you some my lectures, and after that I will introduce the excursion in the afternoon about the lake river canal. So, so two sections. First, my position is a professor of water resources engineering laboratory and division of environmental science and technology. And today I'd like to talk about the hydro-environmental numerical modeling in shallow waters. Especially in this talk, I explain about the flow and the fish behavior model in a practical solution. So some of you may have not heard about the fish wave or fish ladder. Have you heard about the fish wave, fish ladder? No one. The fish wave. Fish wave are the hydraulic structures which enable fish to migrate through obstructions such as wet conservation works or the whales, etc. The RD concern for conservation or improvement of fish-friendly rivers has been widespread in Japan and also maybe in Taiwan. Fisheries have attracted major interest of river engineers and ecologists, as well as inland fishermen. And Kamo River, maybe you can understand Chinese. So Kamo River, this is Kamo River, and we are here. And the fishery, on the fishery, there are many fisheries. This part, like this. So this is the fishery. Actually, very simple, very simple, made of stones. Like this. And this simple fishery, this was made in 2017, but actually, after several days, this was destroyed by a small flood, so easy to be destroyed. So in the following year, this stone and concrete fishery are set. So now still there. So if only putting stones, very easy to be destroyed by flood. And the second one is here. This is these two are the fisheries. This is the but I think this fishway are not good for ascending fish because this inlet here is very shallow and relatively rapid. So I think this is not a good practice, I suppose. And this is during front. 206 meter in one night, 2015. And during the drought, this kind of situation occurred, and in summer especially. But this fishway are not only fish ascend this fishway, but also children sometimes. And third one is this is a wooden type of fishway. But this fishway are temporarily installed by inland fisheries cooperatives or non-profit organizations to migrate, to help migration of the upstream ascending fish. And this will be installed in May and removed in October or November. Not permitted, this is permanent. And this is the fish. This case is the slope type of fishways. In this case, but now still not installed yet. And here also. So this afternoon we will travel across the Kyoto University campus and go to these directions. And here, actually. This fishways has not set installed yet. And this weekend actually this is planning to install. So we can see this type. But you can see another fishway type later. This is just making when they are making. These are the inland fisheries cooperatives and the non-profit organizations, volunteers. And this is pool and fishery types, pool and weir types. And the target fish is ayu. We call it ayu. In Chinese character is ayu. Ayu is a migratory fish. When in May they come from the coastal areas, Osaka Bay coastal areas, and spawn in the rivers. Then late autumn, they go down the rivers and spawn and die. Only 1 year life age. This is a major, the best popular in Japan in inland fisheries, especially in the western Japan. And this is also the flooding. It's running after that sometimes. When we install this during, and also here, this is Sanjo area, the downtown areas, very famous spot in Osaka, the major street. So you can see this kind of fisheries, wooden type of fisheries installed. But this is an old type. So last day I happened to go this area and took the photos. This type installed. This is yeah. So yesterday I just happened to this type of fisheries. The fishery researches consist of three parts. One is the field observation. This is the field observation. And this is the fishery. Fan-shaped type fishery. And this is where to intake water for irrigation. Different areas of Japan, Shikoku area that, and this is me. I'm measuring the velocities in the fishes, and this is a student. Student just pushing the computers. These are field observations, and also the hydraulic model experiment is used for the fishery research to make models in the laboratories and do the experiments. And another is a numerical model experiments. So I focused on these types. There are many difficult point to employ this numerical model experiment because the flow in fisheries are so complicated with free surface, and some supercritical flow conditions exist, and some are the supercritical flow, and the other is the subcritical flow, and they are coexist. It is very difficult to treat numerical simulation for the numerical simulation experiments. So I suppose supercritical and subcritical, that you know, subcritical and supercritical flow condition you have learned. Yeah. I know it's maybe all. Okay. So I just show a simple example. When you throw a stone into a pond, then the liquids spread in all directions. But when the water is flowing this direction, then the liquids forms like this. This is a subcritical flow conditions. The wave can move upstream and also, of course, downstream in all directions. But when the water is flowing very, very fast, then the waves cannot move upstream. The very first, due to the very first flow. So this is the supercritical flow. So waves can move upstream. So people in upstream areas don't know what is happening in the downstream areas because there are no information come from downstream. So information, we cannot get the information from the downstreams in the supercritical flow. But the subcritical flow, we get the information from downstreams and of course the upstream, both sides. That's the difference between critical and supercritical. Much faster than this is like this. And this is formed the shock, it is called the shock wave. So about the numerical experiments, first we reproduce the water flow in the fisheries, and after that we have to release the modeled fish in the fishery, and we investigate the fish movement or fish ascending route by computers. And these are the various types of fisheries which are practiced in Japan. Many fisheries. And you can see this. As for this, all those phases are natural reefs. But these stones are natural, of course, but these stones are put on the concrete bed, so artificial ones. But these kind of fisheries are becoming popular in Japan because it is well matched with the sceneries, and also it also works well as a fisheries. And this is the ice harbor type fisheries. And cool and weir fisheries like this. This is most of the 90% of Japan this type. Very popular and old traditional ones. And this is a vertical view of the structures. And these are the examples of the simulations. When the discharge is large, then this streaming flow occurs. Streaming flow like this. The very first flow occurred in the surface areas. And in the pool, this profile eddy created. And if the discharge is low, become low, this kind of structure flow is occurred. So this is called the plunging flow. And also this in this case there is an orifice here. So very first flow come from the orifices. And in the pools, anti-clockwise eddy occurred. And how to compute the flow in computers? The discretization of differential equations. Difference equation. So in Navier-Stokes equation, there are partial differential equations. And Navier-Stokes equation, the basic equation of movement of flow fluid. So when discretization of the differential equation, this is the differential equations. Just we change this one. So maybe neglect this, and then this is we call difference equations. So how about how about treating the second order difference? Second order difference is also the two times usual differences. This second order differences is like this, then transform like this, and also this. This differential transform like this. So then finally we get this equations, difference equation for these differential equations. So we just count minus and plus. So computer can calculate by example, the heat conduction equations for these equations. We discretize like this. This is the first order discretization difference equation. And also this is the second term, second order, so like this. Then only unknown values is this is the present value. Well, these are all present values, so we know the information, the present values. This is the future values, only this is the unknown. So we can get these values from using these present values. And the differential equation used for the fluid dynamics is usually mass conservation equation. It is called also continuity equation. It's three-dimensional. It's a mass conservation, and it's a continuity. And the equation of motion is an Navier-Stokes equation. This. So these are only first order differentiation, and it's first order, and this is the second. Only these differentiation. Then we can discretize. This is called the unsteady term, and this is the convective terms. And this is the pressure gradient, and the viscous terms. So first we have to how to present the water body. We discretize the many computational cells. And also I use the volume of fluid method referred to both. Sorry. This is at first we get these equations by on the previous slide. So these are future values, and this is the present values. So this value is calculated the both sides of the values, and then get the future value of this. And the volume of fluid method is to present the free surface. Similarly, we discretize many computational cells, and some cells. So in the both method, water body is approximated by a large number of computational cells, and each cell has both functions F. The both function F is based on the concept of a fractional volume of fluid in a computational cell, and used for identifying the free surface. So cell with F values 0 are the void cells, and those with F values 1 is the fluid cells. So the F values between 0 and 1 have a surface. So by solving these convective equations with F, with Navier-Stokes equations, the water surface and the velocity are obtained. This and with Navier-Stokes equations, we got a free surface by using F. So we just calculate these types of full and real type fish rate. There are many full quantities of pipe. And the length is 20 centimeter, and this is the horizontal length is 33 meters. So this is actually the model types and the difference elevation of 4 centimeter. And the gradient is 1/10. You calculate like this. This is the result. This is the result. This is the streaming flow appears on this case. And also orifice is set. Then the discharge from over this liquid decreasing. So this kind of plunging flow occurs. And then a very fast flow from orifices. And these stone elevated fisheries are becoming popular in Japan. And also this is also a simple example of the computational results. So fish ascending and then they take rest in the wake of the wake regions of the stones. And again, fish ascend, then take rest and wake regions as well. And this is a very deep work. With 3 kinds of fish. This is on the left-hand side. There are 2 types of fisheries in stone. This is ice cover type and this is stream type. Stream type is difficult to what to see. Short buffers are put on the bed and flowing like this. So the velocity becoming velocity like this. So upper areas are relatively fast, but the lower areas are relatively small. So fish can go in the lower areas using this lower areas. And also very strong fish can go this way. So no need to wind, just straight, very easy forwards. And this is the ice harbor type. Is the sophisticated type of pool and weir types. And also this is the vertical slope types. So vertical slope fishery are one of the pool and weir fishery types. The vertical slope fishery usually consists of a rectangular channel with a sloping bed that is divided into a number of pools by bar. And this is very slope, and this area is very fast. And this area has velocity very low. So, water flow. How to calculate the water flow, compute the water flow. So, the numerical model developed based on the finite volume method of the shallow water flow equation is related on the portrait with low schemes or implicit terms of momentum and U is the velocity in x direction, and H is the water depth, and V is the y directions, velocity in y directions, and H is the water depth. This is Q. These are the variables we have to calculate. And this flux term is consisted of two terms, implicit and implicit. Navier-Stokes have the unsteady term and the convective term. Convective term corresponds to implicit terms, and the implicit term is there is implicit terms in Navier-Stokes equations. And about the hot liquid, and this is hot liquid. Hot liquid is like this. To discretize the water body, there are many types of cells, computational cells. So I use these hot liquid cells. That is divided in like this. So when conducting a water flow simulation in this lake, for example, a target region is divided into a large number of computational cells like this. So these are the quadriplates, and they are created by a recursive subdivision of a rectangle about discretized boundaries. Quadriplet has these good points. It is generated automatically by recursive subdivision of a rectangle. And the boundary fitted in a fractal extents, and based on Cartesian coordinate. So it does not require for transformation of the governing equations to other coordinate systems, such as curvilinear coordinate system. And the solution adaptive measure is easily employed. This will be shown later. So as for bad point, curved boundaries. Curved boundaries is approximated by stated boundaries. And since quadriplet not structured grid, neighbor finding procedure is necessary. So generally using smaller grids improve the accuracy of the results, but at the same time it decreases computational efficiency. So that is time concept. So to overcome this weakness, the solution adaptive grid is an option. Later I will show you the solution adaptive grids. So let me illustrate how to generate quadriplates. So here, consider the case of two seeding points. This represents a boundary, part of boundaries, seeding point with the subdivision criterion such that the division only occurs when there are two or more seeding points within a computational cells. So at first, quadriplates are generally by first fitting the computational flow domain into an initial unit square. And then square is divided into 4 equal sized cells, producing the measure of subdivision level 1. And each cell considered in turn. And in this case is the only cell containing 2 or more seeding points is then subdivided into 4 more equally sized cells. And each of these 4 new cells are then considered in turn and subdivided if they satisfy subdivision conditions. So the seeding point is only 1 in these cells. So that it satisfies the subdivision conditions, then stop this discretization. And after this one, After all cell is no longer satisfy the subdivision criterion, then step into the regularization process. This is achieved by imposing a maximum cell length ratio of 2 to 1 between two adjacent cells. For example, these two, considering these two, this one and this one, the length of this cell and the length of this cell is not 1 to 2, right? 1 to 4, so 4 times larger. That is not good for the computation. So we have to divide this again to satisfy the cell ratio 1 to 2. So like this. Then neighbor cells, this cell's length is just 1 and the neighbor cells 2. So 1 to 2 is satisfied. This is a regularization process. And this technique is automatically and robust, quick and produce meshes with high resolution in complex geometries. And this is the example of the oblique hydraulic jumps. To illustrate the solution adaptive algebraic, oblique hydraulic jump is employed. This is a computational domain. This is a computation domain. And this is a horizontal channel. This is a horizontal channel. Horizontal channel having 30-meter width and 40-meter length. So at the inlet of this channel, the velocity is 8.57 meter per second. Very fast, and the water depth is 1 meter. This is a supercritical flow. So when submerged, supercritical flow is deflected. This is this wall is deflected. So when supercritical flow is deflected by a converging wall at the angle theta 8.95 degree, the resulting shock wave front forms an oblique hydraulic jump with angle beta. So this is the initial bridge. This is the initial bridge. And final bridge is used for producing this curved converging wall. It's a little difficult. This is the shock wave of curve. This is a model experiment, hydraulic model experiment. So this is the converging walls and the very fast flow coming this way, and this is a shock wave form. So the water depth is in this area is shallow than this area. So this is the oblique hydraulic jump occur. Then this is area relatively large water depths. This is shallow water depths. So at first we calculate the result like this, but using non-adaptive means like this. This oblique hydraulic jump is a little not sharp. This is a contour of the water depth. So the not a sharp wall up here. But if we use the solution adaptive bits, then we got a very sharp shock wave here. Because we use the finer mesh here, so the result is improved. This is just an example of the solution adaptive grid. And this solution adaptive grid is automatically generated by the program. So no need to decide which areas we should use the finer mesh. No need to worry about that. In this program, the subdivision divided, if the water surface gradient larger certain values, then the areas divided and use the final mesh. That is the program. also the solution adaptive grid, the dam break flow. This is a kind of dam break flow. So it's like this. First, this is the starting point. Then, like this. So solution final mesh is used for the where the high gradient of the water surface runs. This is about the computational grids. So smaller grids are used only where the water surface gradient is large to maintain or improve accuracy in the results at the same time computational efficiency. Next speak about how to discretize in the flux form. This flux form is very important to discretize. For unsteady flow, we use the Runge-Kutta schemes to integrate by time. And the flux form terms consist of inviscid flux and viscid flux. And viscid flux is used for the central difference scheme. This is very popular schemes. And here is the non-linear terms in Navier-Stokes equation. So we have to employ a higher order of approximation schemes. So I employ those schemes. So if like this, if we the computer is very computational result is very good approximation. Then this wave move like this, not a deformation. But if we use the BAT approximation method, this like this deformed like this. So we have to consider, we have to employ schemes to maintain these shapes. That is a law schemes I use. So law scheme like this. This is a convective terms equations. So we transform this one and this one. So this is the flux difference. So you the variables changes according to the difference of the flux terms. So this equation is. So for example, this equation discretized like this. This is the flux differences. So flux A minus plus 1 to minus F1. And this is all unknown terms. This is future time in plus 1. And considering this one-dimensional cases, and these are the computational cells. And U is like this. The orange U in J grid. And next grid, J plus 1 grid, is the pink values. And J minus 1 is the green values. So if this C or F flux move like this, then these values move like this. So the flux at this point, is the value of yellow. And but C in this direction, then the water move like this. Then flux in this area, this point is pink values. So flux changes according to the direction of C. So if C is positive, then this value is used, and C becomes negative, then we use this values as a flux. So we have to change the flux according to the C directions. So we have to take the direction of C into consideration when discretizing the convective terms, actually inviscid terms. So expression of the flux is transformed like this in one equation. this flux expressed like this. And for multi-dimensional and non-linear cases, we have to transform the equation like this. This is a non-linear cases, and we transform like this and this. Then it's a bit difficult, but these three independent scalar convection equations will come. So we use these equations like this, using this. So convective equations, we use a function. Flux is expressed like this, and also multi-dimensional cases, flux is expressed like this, so similar cases. This is the velocity, it's called the velocity. And this is the result of the flow in vertical surface space. This is a vertical surface space. And the red region is a relatively high region, over 1 meter per second in this case. And this is the water surface elevation. So this area is also horizontal. And also this is horizontal. And this is the small gradient out here. And this figure shows the free surface in the pool. So these areas are also horizontal. And in and around the slot regions, a relatively large water surface gradient occurs. And this is a comparison of velocity fields between non-adaptive and adaptive fluids. This is non-adaptive cases. And if we use the solution adaptive, then we got these types. So the center of this vortex has to move downstream, and it won't move downstream. And also this is the difference. And if we use the more fine mesh, more fine uniform mesh, we got a similar result like this. So this is more accurate. So next step is the fish movement. So we're moving on the fish movement modeling. So I'll explain about the fish movement. So there are many factors which affect fish behavior. For example, the flow speed and the water temperature, the food distribution, predator, etc. But considering the situation in a fish way, water flow is an overwhelming factor to regulate fish movement. Okay? So considering the situation in a fish way, so water flow is an overwhelming factor which regulates fish movement. Then it is reasonable to introduce Newton's second law of motion for predicting the fish movement. So in this model, two forces are considered. One is the thrust force, and a thrust force for swimming against the flow. Okay. And the other is the drag force due to flowing water. Then equation of motion is expressed like this. So by solving these equations, these differential equations, fish velocity and fish position are calculated. The drag force is usually these types. The drag force is proportional to the u squared. The u is the relative velocity. This is commonly used for the drag forces. And for the thrust force is a unique fish swim, they are known to use two kinds of muscles, the red muscle and the white muscle. So red muscle is used in using cruise, and the white muscle is used in emergencies such as escaping from predator or swimming against a rapid flow. So choosing a cruising speed is about 2 to 5 times of body length. This is body length of fish per second. This is usually cruising speed ranges from like this in like this. And the burst speed, when the fish use white muscles, they can swim in burst speed. Burst speed is 10 to 20 times body length per second. But the fish use the white muscle, they easy to fatigue. They can't continue swimming in burst speed. Only 1 or 2 seconds swimming with burst speed. After that, they have to take rest using red muscles. So in this model, the thrust force is modeled like this. This is using the cruising speed, T cruise, and this is the T max is when they fish use the white muscles using the burst speed. Yeah. So in this case, in this computation, this model, I used U cruise is 4 times body length per second, and the U max is 15 times body length per second. And when the water velocity around the fish is less than 80% of cruising speed, fish is modeled to swim in cruising speed. But if the water velocity is greater than 80% of cruising speed, fish start to swim in burst speed. 80% of cruising speed, then they use the white muscle. So fish can swim in burst speed only 2 seconds in this model, so due to the white muscle property. So after that, fish have to take rest for some time, and after recovering, again, can swim in burst speed. So they swim in burst speed in 2 seconds. They have to take rest by using the cruising speed, and then again next, and the fish can use the white muscle again. And this is about the direction of the thrust force. So to express the uncertainty of biological aspect while choosing the direction of ascending, the stochastic concept is introduced with the normal random variables to model the direction of the thrust force. Then all the fish would ascend in their own directions. The direction of the thrust force theta, direction theta, is modeled direction of thrust force is modeled like this. Theta 0 is the direction against the flow, and the sigma is the standard deviation. But actually, sigma is regarded as the parameter expressing the degree of freedom of movement. So some experiments using feeding fish have shown that fish lose freedom to choose their way as water velocity increases. So this is the theta against the flow, and this is the sigma allowed the random normal variables. And if water velocity around the fish is less than 6 times body length, then sigma is set to pi over 6. And if water velocity around the fish becomes greater than 6 times the length, then sigma is very narrow, pi over 18. And in this model, downstream of this kind of fishery. Then we calculate the fish locations. And first I completed the profile like this. This is the similar the observations. It's the main stream and the decirculation areas. And this is the result of the completed trajectories of ascending fish. It's the body length of 0.2 meter fish. This is the 5 fish results shown on this figure, and only this pink fish can successfully ascend. And the smaller fish it has you can see the difficulty to ascend. Some are wrong again, and then the trajectory is very complicated. That means it's difficult to ascend for this small fish. But the larger fish, the trajectory is very simple, so they can go with no difficulties because the larger fish has a strong thrust force, and younger fish or juvenile has a small thrust forces, so difficult to ascend. But larger fish can easy to ascend. So based on the computation results, more suitable design of fish for ascending fish can be proposed using this fish-based simulator. Yeah, so younger fish, for younger fish, it's difficult to ascend in this type. And about the last agricultural water use. Agricultural water use system consists of an irrigation system and drainage. So irrigation system has a headworks. So main channel and the irrigation channel. And in the drainage system, water flows through the drainage channel and returns to the rivers. It is said that the agricultural land improvement projects conducted by FAO in Japan has decreased the aquatic species in paddy fields because of one of the main objectives of the project is to make larger vertical gap between paddy field and drainage channels in order to dry paddy field quickly. Then, so that vertical gaps become the barrier for ascending fish. So, but these days, to overcome these vertical gaps and recover the migratory environment in some areas, fishways connected paddy field and the drainage channel are installed so that the ocean carps or catfish, etc., could ascend to the paddy field and spawn in it. So then the paddy field function as a nursery for them. So aquaculture water use method simulator is which compute the flow and fish behavior in whole 4 areas. Could be a powerful tool. Powerful tool in designing this kind of system by taking not only water flow but also the aquatic living behavior into consideration. This is fish tray installed in equipped with the weirs, and also this is the paddy field fish.
how long? Yeah. So it means that the farmer need to to get the how long the fish and know the water flow is.
Yes.
It kind of hard for the farmer to do that.
Farmer.
Yeah.
Well, maybe no need to farmer to measure the things.
It means like some person who have knowledge about it.
Knowledge about this. No, just engineers know how to know and just design this kind of systems.
So I mean, we need to know the number and then we can apply to.
Yes.
So it does.
Yeah. How to for engineers just design for 5 centimeter and 6 centimeter, many body sizes
Oh yeah.
Consider.
Oh.
So, but it's important is the minimum size because minimum fish is weak.
So I get what you. Yeah. So can I ask one here? I don't know where is it.
See the number.
Yeah, I don't know. Six in from.
5 or 6. It's 5. This usually the flow is like this and fish. Usually fish against the flow,
Yeah.
and but they have freedom to choose the directions. And this direction is, for example, the 5, 6.
So
This angle.
Oh. Okay. So they already have it. Oh.
But the fish always find the smoothest
Yeah.
way to fish, not the strongest.
Mathematics, so
Mathematics.
yeah. So this guy calculating out maybe.
Other question?
And any questions? Because one of our teachers, Professor Ye, is doing similar things in逢甲University, and we have conduct hydraulic. It's not a computing model. It's a flume test.
Oh, okay.
Yeah. So we have done a lot of because right now we have a lot of check dams. So we have to make the opening and find what is the best policy for considering sediment flow, sediment and also flood flow. And we have to find out that if the sediment will block the fishway.
Yeah.
Normally in Taiwan we have a lot of sediment problem. So that is very important, especially this kind of fishway. I think we have built a lot of fishway, but all of them, especially after flood, almost everything is filled with sediment. So we have to clean it. Clean it in Taiwan. But I think another problem is that we have found that normally in Taiwan the fish do not go into the fishway. They just directly jump. Yeah. But normally like this kind of fishway is installed in larger whales, more than maybe more than 8 to 12 meters high, then the fish will go this way.
Yeah.
But normally the conservation work, like in Taiwan, most of them are established 1 to 1.2 meters. The fish directly jumps.
Oh.
Yeah. So that is another problem. And I think my question is that the fish differs in like in the mountain streams. Maybe the fish are much smaller.
Oh,
Yeah, much smaller. So it is interesting that you talk about the white mussel and the red mussel, because in Taiwan we do not consider the fish.
Oh.
Yeah. And sometimes our residents say you should make the rest area bigger, then we can go fishing. Yeah. But if the rest area is larger, the sediment problem will be enormous. So we have to make a big budget for the government agencies to clean the sediment almost, I think, 2 or 3 months per time. So that is a problem. So most of the fishway are stuck with sediment. So I think that's the reason why the fish directly jump. Yeah.
Oh, okay, I understand. Yeah, some fisheries in Japan also they are filled with sediment.
Yeah, the gradient, I think, like for the river next to the campus, it is smooth.
Yes.
It's not steep.
Yes.
Yeah, but in Taiwan, most of us are more than 3 or 5%, or larger than that. Yeah, and another thing is that in the slide, the first 2 slides. This one.
Oh, yeah.
In Taiwan, we have a policy. We learned it from Japan, and we have figured out that the plunging length from the fishway to the conservation work. We have a role of following that if the fishway width is B, the length of the conservation to the plunging, we have to be 3 to 5 times. So we have to make the pool for the fish. And they said, oh, okay, if this pool is big enough, then the fish can swim to the part to rest. And most of the men go to fish. So this work must be long enough. So if the fishway must be installed, the conservation work must be attached at the same time. We couldn't put the fishway on the second time because it becomes too narrow, like this picture here. We have to avoid this problem.
Yeah, that's a very good point. Yeah, the pool should be installed.
Yeah. So it is very similar to the second picture here because a lot of rocks will stop here. Stop here.林务局最近比赛的都是你们几个老 都有帮忙在做比赛，就是这个类似的东西。
So yeah, this rocks is used to make pool here.
Yeah.
But during flood, there are some.
Yeah. So in Taiwan, maybe if the fishway is stalled, we put on the both sides. We will not allow a big hole in here.
Big hole.
Yeah, this the one on the left side.
Oh.
We will not have this because normally the river will have a big plunge scouring hole here. So normally we will install not in the both sides, or otherwise we have to put in the middle.
Oh.
So no, we will not allow this hole.
So usually this will be set
On the
end of. Oh. Yeah.
And also, we will consider the water amount because normally we will not allow the rest of the river have water come down. Only a step way.
Oh.
So we have to control the height of this area. Yeah. Yeah, we have to control. So maybe from the inlet, we will have a curve down on the open. So all of the water will come this way.
Oh.
We won't let the rest of the river come.
Not let.
So normally this side is dry.
Dry.
Yeah. It's much higher. So we have the design of the conservation work and the normal depth must be, I think, more than 15 to 20 centimeters. So 15 to 20 centimeters, so we will be higher than the water level in normal time. But the water will come to the fishway directly. So we have another design is we have like a U-type U-type concrete here. So then we will not form a plunging wave there. It will be very smooth. And then on the first step we will plunge. Yeah, like this. But if we have the conservation work with then we will have the first scouring problem here. Yeah, normally this will become very big, and in Taiwan because the sediment is enormous, so like the top of the conservation work, we have to change the concrete strength. Yeah, maybe more, and sometimes we have to put steels on the conservation work. Otherwise, it will be worse. Away. Yeah. 吴老师在上课的时候，他会教所有的护船工的顶端会加强它的那个磨石啊，所以它的混凝土的强度会加到280到320，然后会加钢筋进去，啊，那是在水保设计里面啊，这种那个什么鱼道的入口的地方，我们通常不会跟护船工会一样高，我们会把它再拉一个 U 字形下去，这样子的设计，因为他怕的是，因为台湾泥沙很多啦，所以泥沙多的话会磨石跟那个冲刷到他们第一阶的这个地方。我刚才跟老师讲的是这个问题。Design, we have a design class in the fourth grade semester. So we teach them how to design, especially conservation works with fishways. Yeah. And so right now, sometimes the fishway, like our forest bureau
Okay.
in the mountain sides, they say you should not do this kind of slide. You should do a bottle type.
Oh.
A bottle type. So it's like a detention pond.
Oh, okay, okay.
So then the plunge of a wave could have some area to store small or fine, coarse sediments. Large sediments might have the area to deposit. Yeah.
Computation is like this.
Yeah, and we still have the step, but the bottle area is larger.
Larger
To-
ones.
Yeah.
Oh.
One way is that we must force the sediment to go down. Then we can form a restway for some fishes, because some fishes sometimes they will hide inside this area.
Yes.
Yeah. And another question is that the formula that you mentioned, 2 to 5 times bandwidth and also the maximum speed of this.
Yes, yes.
Is this just for the what do you call it? Are you fish?
Yeah, I fish.
Only for the this formula is only for the onion fish,
Not
or for the all the fish?
many. Yeah,
Many kinds.
many kind can apply this.
Okay. So it doesn't consider the age of the fish.
Actually, age of the fish. Yeah, age is can consider in the body length. So
Yeah, body length
body length. So yeah, included.
included.
So,
Because some fish, when they become fully grown, the length is very small.
very small. Yes.
Yeah.
For example, this is body length. For example, one meter, 0.1 meter. Then this 0.1 meter fish with just 0.4 meter is the cruising speed. Like this.
Yeah. But that might be a very big problem, because you have to form many steps. Otherwise, the maximum speed will over.
Yes, very over. So then
Yeah.
it cannot ascend.
Yeah.
That is an important point.
So that's the reason, like NTU from Taiwan University, National University, a professor there has studied that. He has found in some fishways, I think maybe 30 to 40% of the fish die at the fishway. Because like I say, the bottle pot, the checkpoint of the bottle neck normally is fast, so the fish will go through and be hit to the ground, because the force is too big, the speed is too big. Yeah, so that might be another problem if this velocity is too fast. The small fishes will die.
Yeah, right.
Okay, any?
Question?
Okay.
Okay. Yeah. So thank you for your attendance. So we will have 10 minutes
were asking, is there free Wi-Fi in the school?
フリー Wi-Fi が全の
No. Okay. 它是没有免费的。
我想我吃到饱。
This was This was and we had to find the results, how to open it.
Don't scream. They said be silent.
また馬が驚きますので大きな声を出したりフラッシュ撮影はしないでください。よろしくお願いします。
青い物理の行列がまもなくこの辺りを通ります。行列には多くの召し合うのも通りますので、
你要回来，我们要回来，我们要一起拍照。好高哦，对呀、好帅哦。
青い祭りの行列がまもなくこの辺りを通ります。行列には多くの牛や馬が通りますので、危険ですから写真撮影や撮影のために車道には出ないようにしてください。また、音や光に牛や馬が驚きますので、大きな声を出したり、撮影にナッシュ、ストロボなどは使用しないでください。Ladies and gentlemen, the青い祭りプロセッションに行きますよ。The procession will enter outside for you. So please stay on the line and take the procession from this side. As we pass through the outside,
This is recording, right?
你猜在这两个数字中，真的很高。要不然有在说啥？这给你们，有这个，你看还比较。
现在不能过了。对。
你要隔一条街合照。哦，他们两个 P 上去。
现在好开心什么？是别人他们听，然后知道。
对啊。搞笑哎！幸好我没有跟他们讨论。
对。对啊，跟简哥讲，我们跟他们讨论。哦。时间，然后想说都没有结论，然后就。
我们就10点过来的。你们好聪明哦。
啊，有知道吗？真的想考试。就只有确定到，但是没有一个确定。
他们现在应该没有办法过来。
没有办法。 他们拍一下他们在那边。他们代表他们也有参加，那怎么办？他们在对面呢，那对拍一下，他们也在这个里面呢，不然怎么办？我们他现在也没有办法过来啊。对啊，对不对？站在对面，我叫瑞拍你们，这样代表你们有参加，因为你们现在过不来了。对，你在那边，好，让他帮我们拍好。
No, cannot come here. Cannot.
Yeah， 你过来一点。Come together。你帮我，你从你这边拍，你拍过来这样子。
No, cannot cross the road.
Yeah, I know, but he can take a picture with us. Yeah. 快，站起来！看到这两个。哦。他们自拍啊？对啊。你们自己拍照。只能这样，不然要怎么用个人去？太难了。超夸张的。One more picture. One more picture. Right. Here. 特地穿的那么醒目的颜色，笑死！多一点头，离面前多一点头，很多啊，虽然都是不认识的人，很多陌生人。生气，生气哦！为什么这样说？他想被封嘛，他想要回家吃饭，就这样生气。对，就是没有马虎。对。老师这样子出来，好像不止发动。拍过去，哎，我们拍过去，拍过去，来，就是要拿很多的，我看到他们了，我看到他们在哪里？有，在那边后面看到了，有。Ray, come here, please. Here. Take one picture. Thank you. Thank you. 跟你的手。他丑，有很，没有他要录影没办法。有他们吧？有。太好笑了，很荒谬哎，很荒谬啊，真的超荒谬的。试穿看看。好像他们那个有没有按到我自己也不知道哎，看下就按到你的。有没有看？不知道。没有用过吗？ 看不太到，被公车挡住了，就买这个不行的3个。公车挡住了。
快！
Yeah, quickly.
他们过来吗？
关了。
Finally.
他们过来了。看不到。太荒谬了，真的是。好感动骑车，太荒谬了。笑死！没有看到一张是可以的。
没有一张是可以的。
哇，这个蛮
没有一张可以真的，太好笑了。
哦，
太好笑了，隔空拍照。好啊，快点啊，来哦！拍照，不要再看你。
他不是，他是记耶。不是图案。
快点啊！人呢？那个木怎么不见了？木。
哪里来？
谁在这里？
看不到。
没有木，你要前面来啊。OK， 好。OK。好了。瑞好帅哦，瑞整个就是很专注的在做他的工作。
我把很多按照这里。
对，我们都
你要问他吗？
他刚刚问我，然后我刚刚还跟他说 yes， 我想说
看一下那个谢谢你他有按到绿。
有啊，红色那一颗就是。我们先去还车。
好的。去哪里还的？
在前面。
所以他就一定有车，对不对？
不一定啊，就是。
就是你刚刚讲那个嘛。这个都有车。哦 ，OK。好，谢谢。
他还车，他这里还车这个，代表他那里有。
哦，好，没有地方讲。
我都不撕膜啊，我做成膜自己掉啊。我也是啊，就是等那个膜边边自己掉就发现。越膜。妈自己都对焦，可以这样。
你看你有什么？看你有什么？刚不是传说吃牛排？哎，他说挺可爱的呢。对啊，不是啊。哦。他说今天500块而已啊。对啊，看一下。对啊，在哪里？京都料理这个牛排餐厅。这间2间套餐。
是要问这个。来问一下。Is that finished? Finished.
You want to go to the lunch together? Go to lunch?
他们是公主。漂亮。对啊。是，看以前他们也不是白，还是漂亮的。自己编的话，应该。以前的妆都是这样。对啊。小朋友可以三个。
全部の真ん中にね。
真叫他吗？真叫他吗？
全部の真ん中。
好想真叫他。会被公主宠辱。公主嘛。
注意演员们穿着拜鞋什么的，
他们很累啊。
对啊，
怎么可以不要走吗？为什么
他们是从下要怎么这样走上？
好像是从对那个什么神社一直走到里面，很辛苦哎。但是跟我们那个台湾的那种妈祖这样绕境那种很像。
我看看小朋友。
但是他们的祭典好像就很严肃，他们的这个庆典好像太过严肃，非常安静。
标准。
他很认真的从头说到尾。叫他帮他拿下雨了，我们等一下。
Yes.
Teacher want you bring the umbrella for him. Umbrella, his umbrella in the room. Is it in the room? Okay.
Don't know.
You don't know? Okay.
有高雨，下雨。哦。南山下雨没有雨伞哦。
后面里面饭店去拿。
可以吗？
可以。
可是我拿不出来这边。
没关系啊，你再拿给我们，你再拿回来就好了。
会下雨吗？
会啊，你有带伞吗？
带了。
你看
他好像爸是个 person。
对啊。哦。他这个镜头没有办法调吗？他这个太近了。嗯。对啊，他把它调那么近，我怀疑刚刚瑞录的都很近。他有点可爱。就这里可以调，他们应该不知道吧？哦。OK。
So cute。
我们可以不要录了吧？其实。
不老师了。
不要录了啦，好累哦。这还要再录吗？要录多久啊？
不知道耶，我觉得应该没关系。
对呀、只是一个庆典而已。那你怎么关？你帮我关，把它关掉。
那有怎么关啊？
对，
我跟瑞呢？
瑞他去拿雨伞，应该是这个。
这边是那个蓝山，然后前面是蓝山渡月桥。我们刚刚搭了多久的公车？有雨伞呢。我们搭了多久的公车来？40分钟吗？40-50分钟的，应该没那么久吧？不知道，半小时的93号公车过来这边。哦，我觉得还蛮方便。可是这边一看就是那种观光景点，所以人爆多，而且今天还是平日。OK。咕噜咕噜。超多人，人超多，很多西方的人哎，很酷。其他人在前面走，超多人，好专业，还有带公车。老师他们，我们回去好像要写报告。是申请那个吗？读课会的计划？不是，好像是要交给那个院办的。不要以为你走最后一个就可以偷偷跑走，
被发现，
这段不能用，乱讲坏话。
偷偷跳桥自杀。
关掉这段都不能用了。对
啊，就是比较刚好，不会太热，也不会太冷。
就是天气没有太阳了。
对，最好的，不要出来。明天会下雨的。
5-6日好对。
对啊，明天会下雨。
You can take a rest.
我的鱼是很气，
门挂到我包包上，
它一直卡在一只镜头的中间。
杨志宇在欺负我，没关系。
那时候我们在专题是，那时候就我们在搞嘛。
确实有变好，
有好一点啊。那时候后来在调查的时候好像好一点。
太老了。
妈，
你很好看呐。
挂什么啦？你要挂什么啦？
你很好看，你很好看。
不要再塞给我。
是你自己在那边搞我的。I don't know。哎，好酷。对啊，那个秉贤老师的。为什么？楼梯非常跟老师聊天。然后就一段，因为我不确定他要干嘛的，应该交回去给院办的。
剪一个 vlog。
对。老师，你昨天来的？
对。
搞我！对啊，好适合，刚好一人拿一支。
这样了解了吗？为什么叫我们一定要过条往回开？你来过了哈。
哎，这段可以给我吗，老师？老师，这段影片可以给我吗？我录到很可爱的小狗狗。
还是你们先去泡？
这边是蓝山温泉。
对，蓝山它是碳酸泉。
酷。美人汤。
还是你们现在就去泡？我想直接泡到5点
来集合。
对呀，再往上走。
哦。好，在录影。Hello。 你用坏 GoPro 就延毕哦。休学。
休学啊！
好，我也要休学。我们大家一起休学。赞，这段不能用哦。哎、超酷哎、真的这边超酷。哎、老师嘞？哦，老师在前面。我偷拍一下他们。
宿内には行きません。はいはいはい。各この鳥居のところにゲートがあるからね、ここ閉めたらいいんですよ。そしたらこっち地下には入りません。王子はそうするんです。こうベストサイズ。ベストポジション。You can understand the Chinese. 漢字は。採用。
已经哦。喂。已经哦。
京都 Yeah, this area is almost the end of the west end of Kyoto base.
いつも言うけど山並みは変わってない。
楼水。
マウンテン。
楼水だ。
Almost 80 years ago. 80 years ago.
听不懂吗？对啊。
いつもこれ山並みは変わってる。
高他不会放进去，很丢脸。
不会吧？都会自己做取舍的。哦，好想划船。
Lower one.
我也想划。
包包要记得拿哦。哎，对哦，哎，我的雨伞没有拿。对不起。
桌上啊，刚才叔叔。
好啊。
耶！
耶！
可以吗？可以。耶！我要偷偷来。
狂杀小蛙选步，
选步。
有病！这段不能用啊。
我要选步，我要选步。
出菜一样，傻眼。
然后他昨天说他素材他也不会全部都过，他说他就全部整组丢给监狱，
整组剪一剪，然后丢监狱。
我靠！
哦。
这是什么啊？吐东西哦。船。要报废。整组丢监狱哦，素材不会看哦。我们讲话在这里面哦。
真的假的啊
？Hotel 蓝山。住河边哦。哦，这应该温泉会馆。
我觉得我刚刚不然呢？我觉得我就是不能放部分，应该只有那个击杀值的部分。
对，就是下去的部分，下去的部分。
那个有点真的不太能放。
对啊。
欢迎书。
十分止まりや。
その下の方って穴から
大家小心点，不要跌下去。
小心。拍他，摔倒才被起火。
The focus is
2:21分。什么地方？
这里是蚊子圣地，
真的，
这里是蚊子家。
对，我也觉得。
那边有摄影机。
Camera, yeah.
So it's in the system.
In the system, yes. Maybe yesterday.
昨天看的那个系统上面的那个摄影机啊，他昨天给我们示范，他把这个闸门这个给它举起来。
可以遥控。
对，比较遥控。
核心超强。煎饼就是
好，我们就往火车那边走。
嘉玲打电话
小火车有。
接起来是喂，我比
要不要去？
好。今天老师放生嘉玲老师，场面直击，
完蛋了。为什么来那么多啊？傻眼。萨摩奇，樱花麻薯还没有开，对，没有开。JR， 然后贤哥 ，Q 呼
老师怎么样了？
他要自己一个人去划船。然后再去泡温泉。
应该的。
听起来，你们可以陪老师去泡温泉啊。
我不想。
我们就不要泡温泉啊，
老咖啡湿。
对。
今天还蛮多。
感觉。
好。
这边感觉有什么小东西可以买耶？
你有推荐什么
？ice cream 呢？有人喜欢 ice cream，
去买啊！
他在录影。
刚刚还有价钱。
骗观光客。
骗人的。
哎，老师有啊，别吃完，然后。
好快哦！我打哈欠要录进去，算了。
如果你午餐没有开的话，可以去吃某一家那家今天15号有500元套餐，500块日币。平日的话，
我们有传的哦。
有，我们今天有传，群主有传。
那一个就是那个真的要排只有一次，可以自己推荐的话就可以去没差。他晚餐也蛮好吃，可是他晚餐
晚餐也可以啊，晚上去吃好像不错。可是我们不是锁定那个了。
那因为他们还要回神户，因为我们飞机是飞台中。直飞台中。
这边有一只伊努，看起来是腊肠。
哈？你想吃啊？
腊肠狗啦！
看到腊肠，想吃腊肠吗？
我说伊努，有一只伊努，然后你跟我说你想吃吗？
腊肠，
天哪！
要的你的快乐在哪里？
你们要吃抹茶冰淇淋吗？
不要。
谢谢。
你们要先找到啊！啊，你不找到
很多冰店啊，但是抹茶的不确定。
啊，你们陪我去坐火车，我一定会出钱嘛。
他在房间没有，我哪来找那个？
没有办法，我的室友一直在打电动。
他室友是
瑞
ice cream。
他妈要两个都不讲话，把装两个。
快点啊，找到好吃的，大家可以试一下。还是地陪要。
应该这边都买。应该随便一家排队，应该都会看得到。但是，但我们已经靠近超过有高雄。
南山飞高雄。
我要回家。
开车去高雄。
我要回家。
好。
反正应该这边大概是到60。 有一次来比较晚，大概都要
有啊，
天龙寺。
知道没有？哎，你不是要？
有没有玉手可以买？
啊。现在下来一定会走了，一定会。
他下来不会，
我会接住你的，还有 GoPro。
我要先去买。先去买啊！快点啊！我们有要去的就去啊，去啊！
我喝63年。
去年来的时候我也买，因为呢，京都日本然后日本可以盖，就有卖那个，然后那个粉就是那种外面是刺绣，然后是不是感觉整个看得心情好那种？可是我大概只盖了20次以内，我就觉得，哦天啊，这个收拾真的是太花钱，我就放弃了。但是有的时候他
前辈有讲话了啦。
啊？
哪个前辈说他买了也盖了20个啊？
我大。
以前在去大陆，然后你刚的房子应该是手工
我是大一的时候在学校上，然后大3的时候就去找。但我觉得来基本就是比较好问的，就是随便问一个比较可以。我觉得
有啊。
我觉得原来如此。哦，天哪！但是那个应该很重吧？
是酒力系。
但是这个研究室那个的老师好像3个都
拿 GoPro 跟拿酒瓶一样。
我们看
什么东西？
我们昨天他们把我说10号都卖掉。
那个老师好像就我们研究室没有那个酒会，就是只有因为那个老师就是变成都有。
就在我们这里根本不可能发生。
成长线啊，成长线。
大家去
好像很健康不错啊。
然后吃东西。
我们真的都没有这种片。
前两天也是台大民工的。哦，不是，台大土木。然后还有这个。
去年我们是去那个琵琶湖，然后有去抓泥鳅。不是泥鳅，应该是鳗鱼，反正就是琵琶湖里面那一种很滑，然后的那一种长那种。然后可是我们午餐是吃，就是我们有一个硕2学长，他是研究那个鲷鱼，然后呢，他就就是他是真的有一个钓鱼的账号，然后自己用 GoPro 拍，然后就是然后就是可能平均1个礼拜会去钓1次鱼的那种程度，就超爱钓鱼。然后那时候他就是去琵琶湖的时候有认识一个，就是琵琶湖当地那边就是钓鱼的，然后是跟他是钓友的样子。然后那时候那一天我们中午就是一边下着雨一边烤鱼在那里烤鱼吃，就是非常的好笑。
我们授班只会干一件事情，怕骂跳。
中午一边撑伞，然后一边骑脚踏车。后来我发现太危险，我就放弃了。反正总之就是有一只折伞是在那
超累，
水
不要讲好了。
对，就是
说好很快就到了，妈的，现在几点？
对啊，但是像这去年好像
3点25分，
好像算是多还蛮多次，然后就有遇到伞，
这辈子都不能骑。我想看电影，我不想走路，很累。
没有任何的求生欲。但是我后来，我觉得雪跟樱花真的不一样。我觉得雪真的是看一看真的。拍我，好呀。
拍你们3个。
就冲到外面。然后后来我跟我朋友飞，然后
耶！
最終列車朝霞55号。どうぞホーム足元降車番号に進みください。睡。
好，我没有坐过阿里山小火车。
我也可以啊。
ホームへの階段が60段ございます。お乗り遅れございませんよ。ホーム足元降車番号をお進みください。
还有规定说站票只能在哪个
念，我们是那个龟山嘛，还是什么？那念龟吗？
对啊，
龟山到冈，
龟山到冈山，
龟冈，
龟冈。
换路线
干嘛？换路。
看合照。
等车子来再拍一张啊！1、2，有吗？1、2、3 ，Good。我说我那个学妹就是他们就做这种边坡的，他们是负责 JR 的所有的边坡巡检。他巡完
念书，
中央大学，州 University， 博班啊，只有念博班。
所以但是他有来这边，我就是觉得有差在这边，就是有多长时间可以那个救护，但是我感觉那个应该还没出来。我回去再查看看，我现在有登录一个救护 APP 的会员，看可以那个。我真的觉得日本人很爱搞这一套，就是你越来越多人，可是有那个会员的那个可以做的事情就超丰富。
但你就是女生啊，你进那种很老的那种企业，你自己要有心理准备。就是你会被，
我觉得这个东西就是台湾比较